A few months ago, the VectorBT Pro expert wrote a script for us that can manage multi-take profits, limit order expiration, and order expiration. We now want to offer this script to you completely for free. It's a highly professional backtesting tool, and currently it's the only backtesting library that is still supported and updated. You can backtest your daily timeframe signals, for example, on a 1-minute timeframe resolution, or even on tick data if you're into that. And you will get insanely high speeds due to the vectorization of the data. So this means, for example, for the Binance universe, if you have like 350, 380 assets, you can backtest them in a 3 years period on the 1-minute time frame in just like 3-4 minutes, which is pretty crazy looking at the amount of data. During this video, you will also get some amazing insights on how to backtest, because Chad is really an expert on that field. Check out his channel and subscribe to the channel. Also subscribe to our blog research channel if you didn't do so, and join the Discord server for more community and more questions about anything regarding quant trading.
Yeah, this is the data folder here, and then that's basically how this is working. So it checks if that data folder exists. If it doesn't exist, well, if it does exist, then it just brings the data from there. If it does, then it fetches it from Binance. Again, I'm sure you have your own data gathering systems that you can get your data from. The next thing is we need to collect our signals, and the signals need to be in the same format as the price data, basically. So you need to have a data frame. So if I get like, data.get close here, you need to have a data frame that looks exactly like this, but is full of signals like buy or sell. So that's what this horrible function does here. I'm sure you can go through it afterwards, but I did, as you said, like I built a bunch of these CSVs here, and they look kind of like the ones you sent me, where it's just, this is daily data. There's a limit price, which is just some random price, long condition, buy or true or false on that day. And then essentially what I did is I resampled this. So if it says true here for the 8th, then I took that to mean at midnight on that day, trigger the buy signal, for example, on that first minute. You can change that however you want. I don't know. It depends on how your signals are generated. You'll want to avoid look ahead bias and that kind of thing. So that's basically how that works. And then there's this whole horrible series of stuff that I do here to get them all organized. But at the end of the day, you end up with something like this. So the true signals are quite rare, obviously. So basically none of these are true. But we could filter those down if we wanted to. And then I do the exact same thing as I did here for the entries for the limit price. So the limit price also has its own data frame with all the different prices in. It's -1 just because all of my entries are on midnight, like I said. So if it's not midnight, then we need some other value in there that's kind of like a null value. And it has to be the same type as the price data. You can't have like a false in there because that would be a Boolean. Otherwise, like Numba complains if everything's not consistent data types. So I just use -1 in there. So yeah, so we have these 3 data frames now. We've got the price data frame, we've got the entries data frame, and we've got the limit data frame, and they're all exactly the same shape. So if you do like dot shape, they're all exactly the same, basically.
The limit data frame doesn't give the limit. It gives you the limit price. Okay, and then it's the false is always -1. I got it.
Yes. So let's say that this signal was true here at this midnight. The limit order would be put through at this price. So if like this signal was true.
But why is it at that daytime? Why do you have a price there?
Oh, as in, so I just put like if we open up our signals here, I just have a limit price for every single bar, regardless of whether it's true or false. I guess in reality, like if you were actually doing this, you'd probably have just like, if it's a false condition, then you just have a -1 there. It was just the way I generated these signals. Like I just built a script that did this for me. You would probably only have a number there if it was actually true, right? But it's just the way I generate. I'll send you all this folder so you can play around with it. But don't say it. Right. Okay, so that's all our data stuff done. That's probably like 40% of the problem. It was annoying to deal with that. But okay, and then there's lots of configuration stuff. I'm sure. Yeah, you said you read through the from signals, like the TP ladder stuff, or at least you had a look at it. I'm using a similar sort of idea here. So this is kind of where we'll do our configuration and how we're defining the configuration. So the config like itself, where you'll specify all your parameters, is a named tuple. So I don't know if you've come across that before in Python. Oleg's very fond of using them. It's basically just a class that like wraps around a tuple and allows you to nicely refer to all of these different arguments. So later on, when we're trying to, it's nice because you can use it with Numba and you can compile it. But at the same time, we can just, rather than having to index into this tuple, being like, oh, I want the 5th element or something, I can just say, oh, I want the TP%. This is the config. This is just like, you know, TP1's at 5%, 10%. Everything you asked for is in here. You specify how long in seconds you want the order to be active for, the trade time, that kind of thing.
Percentage is always looking at what is left, right? If you want to have 3 times 25%, you have some very weird numbers there.
Oh, sorry. So this number here is this is the threshold. This is like what price it triggers. And then what I did is I recorded the initial, whatever the initial buy is, I recorded the size of how much of the asset we bought. And then I just sold, like, so if you bought 1 Bitcoin, I record that we bought 1 Bitcoin, and then you just take a percentage of that. So that the first take profit, we sell 20% of it, 30% of it, 30% of it. The final one here I set to 100%, just in case there's any weird rounding errors. It just makes sure we get completely out of the position on the final take profit. Yeah. Okay. This is like, okay, so now we get to the order function. Don't know if you've come across this before. There are a few examples on the documentation that I can link you to, and maybe you'll see some simpler examples. It looks kind of overwhelming, but it's actually quite simple. So from signals is kind of it's the simplest one, especially if you've already, you know, it's often the one that you first use. I find it to be annoying when you want to be really specific about, like, you know, how do you want your stop loss to execute? How do you know, when you really want to get into the details, I prefer order func.
Okay.
And so this is essentially an event-driven backtester. So there's this C here, which is like a context dictionary, and it gives you a bunch of information about what's going on. So the backtester basically just iterates through every row in your price data table. And we kind of simulate what happens at that point. So for the first row, you know, what do we do? For the second row, what do we do? And so this is basically just walking through that logic. So, you know, we get some variables here. So
can you go a little bit more into the C?
C, yes.
What it's doing?
So let me the Zoom isn't letting me open a new tab, but I'll just, I'll just go look on the documentation here because I can show you what it looks like. So you may have seen it, but it's kind of unclear in the documentation if you look at it. So like if we go, I don't know, let's say we go to the from signals tutorial. And if you look at anything that's like relatively advanced, so if we go down here, it's like TP ladder, you'll see there's always this like mysterious C in here. And it's kind of unclear where it is. And basically what happens is that to every one of these, like, you know, this family of functions, a particular dictionary is passed through, and it's different depending on the function. So for signals here, it's like signals, if I can, signals context. Oh, it's like signal context, maybe. Yeah, signal context. And so this gets passed in at every stage of the simulation. It has a bunch of helpful information in it, like what row are we currently in the price data? Like which column are we looking at? Like, what asset are we simulating? I think it varies depending on the function. So it looks like this one doesn't have as much info, but it has like the stop loss information, for example. Things like that. So this is the signals one. We're not actually using that because we're using a different function. We have order context. That's the one that we have in the order func. This one again has a bunch of stuff, but it has a lot of nice things. Like you can look at the like the total value of the current of all the assets in our portfolio, for example, and that's how I'm calculating our entries. So you know we want to enter with 5% of the portfolio, but if we don't have 5% of the cash remaining, we don't want to do anything. So that's how I'm doing that kind of thing. Basically, if you read through this in your free time, and there's a bunch of helpful information. And this gets passed in every single time you do this simulation, and it always gets updated with whatever the newest value is. Okay, so and then this function here, this is just like a built-in. Basically, it takes the context and then finds like, so the current state of the simulation, we could be like BTC USD at 3:01 p.m. This is like, you can imagine that's where we are in the simulation right now. And this allows us to get the high, the low, the open for the specific bar that we're in right now. You could do it manually, it's just effort. And then at this stage, it's, to be honest, relatively simple. It's just about defining, like thinking logically how you want your simulation to work. So what I've got here is, if we don't have a position, so in this current asset, if we don't have a position in the asset that we're using right now, what I'm going to do is I'm going to check if we have an entry signal right now. If we do have an entry signal, well, I'm going to edit this array here. And this array has a bunch of columns, but it has one column for every asset. So it's like a storage where we can store variables pertaining to this specific trade, basically. So what I'm doing is I'm saying I want to like start looking for opportunities to buy in, basically at my limit price. So I'm activating this variable here. It's just a placeholder variable. Then I get the limit buy price from that limit prices data frame we had before. I also record the index at which it occurred. That's quite important because we want to cancel the order after a certain amount of time. So we need to make sure we know the index. So basically, whenever we get an entry signal, record a bunch of data about what happens and then just continue. And then if the limit order is active right now, then we want to check if it's filled, basically. So, well, we first check if too much time has elapsed. That's all this is doing here. It's just doing some calculations with date time. And, you know, if it's too long, then we just set the order to false, and that's it. Then this stuff here, basically we're just checking for a fill. So if the limit, if our if it gapped up, for example, and the limit price is higher than the open, then we just assume that we buy at the open. If the limit price is like inside this bar somewhere that we're currently in, we assume we just got filled at that price. And there's a whole bunch of like different parameters in here. So like you can see I'm using the investment per. So our investment per is like 5% or something. And there are a bunch of these different like settings you can set the order to. So this one's to value percent. I'll see if I can find those in here. So like size type. Yeah, so there are a whole bunch of different things you can do. So you can say amount. So like I want to buy 0.5 BTC. Or you can say value. I want to buy $1,000 worth of BTC. There are all these different options. I think the one, what did I use? I think I used value percent. So this one. And if we scroll down, it's like the percentage of the total value of the portfolio, which is, I assume, what you're after. If not, it's relatively easy to change it. You can just, pick your different logic. So that's how these orders are working. And allow partial is equal to false. This is just to make sure that, if you're 99% allocated, this makes sure you don't take a position that's too small. Obviously, if you don't want that behavior, you can change it. And then if none of this happens, if we don't buy or sell anything, just return no order. And so that's the logic that happens if we don't have a position, basically. And then if we do have a position, we have to go do loads of stuff. We have to check about our stop loss or whatever. I don't know if you have any questions about what I've just gone through here.
No, very clear.
Okay. So then after this, so this is assuming that we have a position, right? Because otherwise this if this would have returned no order. So this is assuming we have a position. What I do here is I check if a buy order has just gone through. So I'm getting the last order here. I just copied this snippet from the documentation. And if the last order is a buy order and it occurred on the previous candle, then I want to set everything up to get our take profit stop loss ready. So I reset all the parameters firstly. So I make sure that the TP1 was not hit, TP2 was not hit, etc., etc. And I'm again saving this in this like memory that we have. We have like an array where we store information about each asset. So this is going to be stored in the ladder state for Bitcoin, for example. And then again, I'm just filling in a bunch of information here. So we need to know when the order was done. So because obviously we need to know if the order's expired, like if it's been in position too long. So we record that. We record the price so that we can calculate if the take profit's been hit. The size of the order, because we want to do, we want to sell 10% of the initial order size, for example. We set the stop loss price, the take profit price. This is obviously set to just the initial one. So whatever that is. And then we set the take profit percentage equal to, TP1%. So this is just getting a bunch of parameters ready if a buy order goes through. And then at this point, similar sort of thing that we did before here, where we just check the time in position. So that's like, just a bunch of math involving, how long has it been since the order went through? And if it has gone through, if we've been in that position longer than the amount of time, then just sell everything. So minus np.infinity means just, sell the maximum amount. Then we check our stop loss. So we want to simulate pessimistically. So we want to check the stop loss before the take profit. This is again just some basic logic. So if the open of the bar is less than our stop loss price, then we want to sell because the price has gapped down. Or equally, if our stop loss price is like inside the range of the current bar, then we assume that we got stopped because we want to simulate pessimistically. This thing here, this is just a simple. So if we don't get stopped out, well, we now want to check whether we should move our stop loss. It's just checking the price here. And if the price has moved up by more than our amount, we just set this new stop loss, and yeah, we just set a new stop loss price basically to our init price. That's all the stop loss stuff. And then taking profits down here. Basically the same thing. I did this in because we have so many take profits here, it's annoying to have to like check, if this was hit, then send this order. If this was hit, then send this order. So I built this bit of logic here, which basically says if we've done a sell order, well, that's if we've done a sell order and we have a position, well, obviously that order was a take profit order because our stop loss gets us out completely. So if that happens, then here we kind of want to bump up to the next level. So if the take profit 2 was hit, so this is if the last order, I think how I did this. Regardless, we'll see in a sec. So if the last take profit was hit, then yeah, I labeled that wrong. That's take profit 2, that's take profit 1, I think, and that's take profit, I guess. Anyway, I've labeled these wrong, but the logic still works. If the last take profit was hit, then enable the next take profit basically. So if TP2 was hit, enable TP3, and set the appropriate prices. So set TP4, TP4%. And then that's just kind of setting up our parameters. And then here it's basically checking if the TP was hit. So, if just checking the price essentially as we've done before. If the TP is in the current bar, then we hit it. If it's gapped up, then this happens. And there are different execution prices here, obviously. So if we gap up, I assume that we sell on the open. Whereas if the take profit gets hit mid bar, I assume that was just hit then. And again, we do that trick where we sell only the amount of the asset that we want to. So we're selling an amount, and then we're selling the take profit percentage multiplied by the initial size. So, if we bought 1 Bitcoin, we want to sell 20%. It's just going to do that. Okay. And then, yeah, so that's all the logic in here. I find the order func relatively straightforward. You're just defining your logic like straight up as you would normally do it. And this is like most of the code. Like the rest of the code is literally just feeding this function in here. So I'm just feeding it into from order func and then providing it. Let's run it. I guess let's run it here and see what happens. That was pretty quick because I'd already recompiled it. You may want to change this logging here. I was just using that for development purposes. And then you can get a list of all the trades that have happened. So we can investigate what happens with a particular asset. So let's have a look at this XMR one here. So there's like a built-in graph that you can use. So I'll just use that. It gets a bit laggy when there's too many bars. So you may want to, I don't know, you may want to build your own graphing thing. So it looks like what's happened here is, yeah, so it buys in there. It's taking like 5%, 10%, 15%. And then it looks like it's just how like 21, 53. Yeah. So this is, and then it's getting stopped out after 7 days or whatever. That looks like that's what's happened there. And I guess we can vary the parameters here. So I can show you what happens. So rather than a 5, a 10, and a 15, let's change it to like a, like a 1, a 2, a 3, or 4 or something. 1, 2, 3, 4. So you have to run this cell again, make sure that gets done. I don't think you need to run this again, and then we can just run the simulation again. I think it has to recompile again because we changed the data. But yeah, this will do a bunch of stuff. Let's hope this works. Yeah, so it looks like it's filling them all down there. Obviously, we are making assumptions here about the liquidity available at these prices. You can it's quite easy to add like slippage in, for example. So if you go just to any of these orders, there's another thing in the docs here. So if you go to like order NB, so just the function that I'm using, you can see all the different parameters here. So you can, if you want to add, say, 0.2% of slippage to your stop losses or something to simulate a market order, you can add that in there. I didn't do that just for demonstration purposes. So we can see exactly what prices we get filled up. So you can see this is the return here is 1%, 2%, 3%, 4%, and then we're out of the position. So it looks like our take profit is working, which is nice. I guess. So that's like, we're looking at individual assets here, but of course this whole thing is simulated as a portfolio. So it's actually quite easy to do that. Pretty much you just do this option here, this cash sharing option. And this forces, if you don't have this enabled, each asset will run like siloed off from each other as if it's its own backtest. But if you do enable this, this forces them to share the amount of cash that they're using. So I think I set it to be some really high number. I think I set it to be like 40% per position. Let's have a look. Yeah, it's like 40% per position. So basically it shouldn't take more than 2 trades at once unless we're in some really extreme scenario where our our assets go down relative to our cash. Okay. So yeah, I don't know if you want me to try.
How would we see somehow that the trade was not taken because of insufficient funds?
Yeah, so I guess the easiest way to do that is to maybe we can add like a bunch of, we can maybe we can fiddle with these signals here. So we could maybe put through a bunch of signals that aren't like, we could just make it true for all of them or something. So let's go BTC USD. That would be the easiest way I can think of showing this. Or actually, maybe let's go look in here. So we can look through the trades, and I've sorted them by time, so we can see if it ever buys 2 assets at once. Like obviously, I set the trade. The trade signals are just random in this case. They have like a probability of 10% of occurring. So they're not usually that close together. But let's see if we have a scenario where there are 2 trades close together or, taking place simultaneously. So this one, it looks like it got out here. This one, yeah, so nope, that's not. Yeah, because if there aren't any, we sell. Yeah, okay. It looks like, yeah, there's still a Monero order on from over here somewhere. So, okay. Yeah, we probably want to build some tools to analyze these because otherwise it just gets annoying. But so it looks like this ADA position and this Monero position are coexisting here by the looks of things. Because it's it's selling this after it bought this. So let's plot those out and see what's happening. And then what I can do is I can set the allocation to like 80% or something, and then we can see it only took one of those trades. So Monero. Yeah, these plotly graphs aren't friendly on 1 minute timeframes. So looks like we have a sell at this time apparently. 23. It's on the 23rd. Oh wait, actually, sorry. I was wondering why that was wrong there. It's because I didn't run it again. It's stupid to know, but I forgot about that. Sorry. So now it should be correct.
Cool.
I was panicking a little bit there, but I just realized I forgot to run the cell again. So okay, so I'm going to do the same thing I did before. I want to look just where we had two positions at once, basically. I'm sure we could make some kind of graph to make this analysis easier, but okay, so it looks here. So we bought some BTC and then we bought some ETH, and then we sell them afterwards. So we're holding two positions at one point. On this day here. So I'll just copy that and save that so that I know what day that was. So what I'm going to do is I'm just going to tell the simulator to allocate 80% of the funds, and then it should only take one of those positions, obviously, because it no longer has the cash, and hopefully it'll work. So if I set that to 80%, and then simulate. Should only take one of those BTC positions. I guess I can save this here and I can run this in like a new cell just so that we can compare. So if I go to that date, which was the 27th. Yes, so it no longer buys the ETH at this date. So it's buying the BTC, but since we allocated 80%, it's now saying, look, you only have 20% of your cash available. You can't buy that ETH anymore. So if we go to the 27th here, 27th, yeah, it would buy the BTC first, and then it should have bought the ETH 3 days later, but because of our allocation, it didn't do it.
Yeah, nice.
Yeah.
Chad, this is absolutely amazing. Great work. Thank you so much.
Nice. Very good.
Very well built, very well documented and presented. Super thankful. Great work.
I'm sure. Yeah. Yeah. It's Vector BT is a little bit hard to get your head around at first, but I honestly think the from order funk is it's in the documentation. It's kind of the more advanced way of doing it, but I think it's easier, to be honest. And I don't know, speed shouldn't be an issue because everything's compiled with a number. So I'm backtesting on 1 month's worth of data here, but you can run this on as many months as you want.
Amazing. Great.
Yeah.